The effects of freeze-thaw cycles in prawns. In this experiment, prawns are subjected to 3 treatments, 0, 4, and 8 freeze-thaw cycles. There are 2 parts in this experiment. First is to determine the alpha-glucosidase activity. Weigh about 5 grams of prawn sample. Put the prawn sample into blender. Add 25 ml of deionized water into the blender and homogenize the prawn sample with it. Pour out the blended sample into clean centrifuge tube. Centrifuge for 10 minutes at 10,000 rpm. This is how it looks after centrifugation. Decant the supernatant and note down the volume. In this video, the volume of supernatant is 17.5 ml. Repeat the steps above for all 3 samples. The following will be all the reagents and materials needed to prepare for part 1 of this experiment, which is to determine the alpha-glucosidase activity. First, add 0.3 ml of 0.1 molar sodium citrate into a clean centrifuge tube. To the same tube, add 0.2 ml of 1 molar sodium chloride. Add 1 ml of the prawn supernatant. And lastly, add 1 ml of 4.2 millimolar PMPG. Repeat the preparations for all 3 samples. Put all the 3 tubes into water bath at 40 degrees Celsius for 45 minutes. After 45 minutes, terminate the reaction by adding 1 ml of 0.3 molar potassium hydroxide into each tube. For spectrophotometry, prepare a blank solution containing 0.3 ml of 0.1 molar sodium citrate, 0.2 ml of 1 molar sodium chloride, 1 ml of 4.2 millimolar PNPG, 1 ml of 0.3 molar potassium hydroxide, and 1 ml of deionized water. Read and note down the absorbances of prawn samples in the 3 tubes using spectrophotometer at 405 nanometer wavelength against the blank solution. And we are done with part 1 of this experiment. Moving on to part 2 of the experiment, which is to determine soluble protein content of the supernatant. To begin, we have to prepare protein standards to construct standard curve. Prepare 4 standard solutions, 0.25, 0.5, 0.75, and 1 mg per milliliter BSA standard solutions. This is how the 4 BSA standard solutions are prepared using 1 mg per milliliter BSA and deionized water. Transfer 0.1 ml of each standard prepared to clean centrifuge tube. To each 0.1 ml standard, add 5 ml of bio-red dye reagent. Cover the tubes with caps and mix by inverting several times. Incubate all tubes at room temperature for 30 minutes. For spectrophotometry, we have to first prepare blank solution containing 5 ml of bio-red dye reagent and 0.1 ml deionized water. Read and note down the absorbances of the 4 BSA standards prepared previously using spectrophotometer at 595 nanometer wavelength against the blank solution. Use the values to plot the standard curve. Now, the absorbances of prawn samples are to be measured. Each prawn supernatant is to be diluted 10 times by adding 0.9 ml of deionized water to 0.1 ml of prawn supernatant. Add 5 ml of bio-red dye reagent to each diluted prawn supernatant. For this spectrophotometry, prepare the blank solution containing 1 ml deionized water and 5 ml bio-red dye reagent. Read and note down the absorbances of all diluted prawn supernatants using spectrophotometer at 595 mm wavelength against the blank. And that's the end of this practical.